Alright, let me talk you through how to do question 5. So I didn't really discuss this in detail, but it's in your green notes. So let's have a look at it. So find the equation of the resulting graph when f of x equals x to the power of 2. So you know that if you graph it, it looks something like this. It's a quadratic form. And let's say it translates through this vector. Alright, so if you're looking at it and going, what is going on? It's because I didn't really talk you through it. But we'll give it a go. So let's go back to our notes. And it's just basically the last point here. So it basically says if your graph is moved by negative b in the inside and then plus a on the outside, it actually is also can be written as this vector, right? So this is a vector. So we basically just use that same analogy. So when it's a plus a on the outside, it becomes a plus a. So let me start there because I find that one easier. So let's go find our question. So in our case, my vector, a, it was b comma a. It was this one. So that is just going to look, it's going to be added on the outside of the function, like so. Okay. Well, let's come back to this one, h. So as you remember, let me go back to it to show you. It's not going to be a plus h. It's actually going to be a minus h. Hopefully you can see that. Let me zoom in a little bit more. So you can see that this positive b is given by like opposite minus b. So in the inside of the function. So you have to consider to put it in the inside of the function. So I'm going to edit this a little bit. So basically inside there I need to change it to a minus h. So that's what I'm going to do. So it changes to x minus h squared because that's the function, and then that plus k because we figured that out before. So that's what it looks like. And if you have no idea what the next part says, let's have a look. Discuss how the equation you have found, so this equation, provides the coordinates of the vertex of the translated quadratic. So as I said, this is called a quadratic, and vertex is just a point at the minimum or the maximum. So I didn't really teach you this because we'll learn a little bit more in polynomials, but if you don't know, Google it. So I've Googled it for you. Vertex form, what does that look like? Well, let's see if there's a bit of a better example to look at. Here we go. So let's have a look at this one. So as you can see, apparently a vertex form of parabolas is given like so, right? Why don't I copy and paste it just so we can have it right next to the work we are working on. So I might paste it over here so you can still have it. That's what the vertex form looks like, and have a compare it to, excuse me, compare it to what we have. It looks pretty similar, doesn't it? So as you can see, we've got a negative h and we've got a k. So we actually have our vertex h comma k. So all your answer is the vertex is just h comma k. Now, depending on if that h is a number or if that k is a number, you will actually have coordinates of that vertex, meaning this minimum point of that parabola, which is pretty cool.